We weren't really planning to start in this video like this, but we just got laughing. It just happens with Mr. Spencer and I.
So
today, focused. Hooyah. Here we go. Today we're going to talk about speed and velocity calculations. And hey, I spelled your name right again.
I appreciate that.
You know, I didn't want you mad at me anymore. So, we got a bunch of fill in the blanks.
Fill in the blank stuff.
Now I got to remember what I said the blanks were going to be. Anyway, so the speed is just the amount of distance covered in a specific amount of time. Okay, so usually when we're talking about distance, we're either using meters, we could use kilometers, we could use miles.
We could use light years.
Wait, that's a time. It says year.
But it's...
Yeah, I know. I had
Take astronomy.
Take astronomy. Yeah.
Yes.
A light year, guys, is a distance, not a time. Moving on. And when we're dealing with time, we're usually dealing with seconds, minutes, and hours. Okay, it could be something else, but those are the ones we're usually dealing with. Now, the only thing is sometimes I might give you a speed or velocity in miles per second, and then I also give it to you in miles per hour. So you got to remember we have to do some conversion, and we'll show you guys how to do that a little bit later. Okay, but then what's this scalar, Mr. Spencer?
So when we talk about scalars and vectors, scalars are just how much. All right, so if I'm talking about like driving on the highway, and I'm talking about the speed, I just want to know how fast we're going. Okay, so it might be 60 miles an hour, 70 miles an hour, 120 miles an hour if you're Mr. Conrad. All right, so it's just it's how much or how fast you're going.
So usually when we're talking about speed, we're just talking about a number.
Yeah, yep. Just a number with a unit.
Just a number with a unit, miles per hour. Now, that's not how we normally are going to be writing our speed. Usually we'll be doing something like 60 miles per
hour. So it's a unit of distance per unit of time.
So it's a unit rate.
Of time.
Yep. Unit rate is usually what we're dealing with. Velocity is almost identical. There's just one thing that is different. So again, this is the amount of distance covered in a given amount of time. But here's the huge difference here. This one has a direction. So like you were saying earlier, if we're going down the highway, we're going 60 miles per hour, but we're going to go west.
Yep.
Okay, so usually it's the exact same thing. This is our scalar, but then the west part tells us the direction that we are going.
Yep.
Okay, so our equations, you guys, are almost identical. We have speed is equal to distance divided by time, and velocity is also distance divided by time. It's just when we write our answer for velocity, usually we would add a direction to it. Okay, now I know some of you have seen these equations before and you like using this little triangle method to work through that. I personally am not the biggest fan of that because you have to learn how to, manipulate an equation, but I also at the same time it is an easy way, it's a backup way. So distance and time go there because in our actual equation we're dividing our distance and time, and then velocity or speed goes in this corner. So if we wanted to solve, if our unknown was our distance, we would just cover up this top part like that, and we just do velocity times time to get our answer.
Distance.
Okay, and then if it was we were solving for time, we would cover time up and we'd do distance divided by velocity. Okay, so that's how the triangle works. I'm sure most of you guys are familiar with that.
Oh, the good old guess method.
Yeah, because we just guess at what the answer is. What's the point?
No.
But that's what guess means.
No, we're gonna teach them how to do this because, and this is where people are like, oh my gosh, why are you making this so long? I can just do this in my head. Because you have to have a plan for how you solve things. And yes, there are certain kinds of things that you can do in your head
and you can do real quick. But some people aren't always the greatest at math.
Right.
So this is just like kind of a foolproof way. If you struggle with working through calculations, this is an easy way to kind of help you work your way through the problem.
Exactly.
So what does the G stand for?
That is for given. All right. So what it's saying is every problem they give us certain information. So like sometimes they might give us the distance, they might give us the time. What we want to do is make sure that we write those things down.
So like if we're dealing with our velocity versus time, or velocity equals d divided by t. So in our given, if I give me a distance, I would write down d equals here, and I would write whatever that distance is.
So
and then I would also put down time if they gave me a time, and that's under my given.
Right. So one of the things that we have to remember there is we want to give the number, and we also want to put the unit in there. So if it's distance, if it's 60 or 100 or 10 or whatever, 100, okay, it might be meters, okay? We don't want to just put
100. You have to put the unit with it. And let's say time, let's do 10 seconds.
10 seconds, all right?
That could be minutes, hours, but we're just chose seconds for this example.
And I think one of the things that's going to be important as they're figuring this stuff out is sometimes it doesn't say specifically the distance is 100 meters, the time is 10 seconds.
You have to be able to read it and figure it out. And we'll get to that when we get to the questions, you guys. U is for?
Unknown. It's like what we're trying to find. All right.
Into the unknown. No.
You could keep singing if you wanted to. That's
into the unknown.
So that's what we're trying to find. So in this case, we were talking about and I like to put that the V with the question mark in there, or the unknown with the question mark in there, because it just kind of reminds me of, hey, this is what we're actually solving for.
Okay, now E is for equation. And I already wrote the equation down up above, but that was just kind of like a reminder. So once you get to the equation part, V equals D over T. If you want to, could they write the equation down first and then go back?
I like to do that just because it helps my brain keep
track
focus,
of
keep track.
What variables I need to have, and then what ones I need to solve for. Okay. Now S is
substitute. So we have our equation. In this case, it's V equals D divided by T. So now we're going to set that up as V equals.
Instead of writing D, we're going to write
100 meters.
Okay.
And instead of T, we're going to write 10 seconds. So we're substituting the givens.
We're just taking this there. Right here and plugging it in here. And then we're taking our 10 seconds and we're plugging it in down there. Okay.
And now we solve this puppy. So we take 100 meters divided by 10 seconds, and that's going to give us 10 meters per second. And you circle that to make it easy for people to find.
Yep. That's really not that bad. So again, given, our guess method is you write down what's given, then you go to the unknown, your equation, substitute your values in, and then solve that. Okay, let's take a look at our first couple examples here. So our first example is a vehicle travels 2,304. I just really went with 2, 3, 4, 5 because it was just fun to say. Anyway, meters in 315 seconds.
Okay.
Travel towards the evening sun.
Ooh.
So this sounds like it says, what is the speed? Are you okay?
I don't know. I'm trying to think of where the sun, sun rises. It's in the east, right?
Yes.
And it sets in the west.
So this would be going west. So this really, we could make this into a velocity.
Okay. You could, but
it says, what is the speed? So we're just looking for a number.
All right. So I'm totally interrupting you right here, but I think this is like when we're working out problems, this is that's some of that extra information that you might not need. All right, so you have to be able to figure out, okay, do I need this or not?
So towards the evening sun is just kind of extra information on that. So I'm just going to cross that out.
All right.
So we're going to go through our guess method. So again, G is for given. I'm just going to write the equation down first just because I would much rather write that down. So D equals D over T, or S equals D over T, excuse me. So I know I need to have an S, a D, and a T. So it says the vehicle travels that many meters. Well, meters is our distance, so I'm going to put D is equal to 2, 3, 4, 5 meters. Okay. And then they also tell me a time, which is 315 seconds.
Okay, so this is just me being nitpicky. Can we put T equals 315 seconds?
T equals.
There you go.
I forgot to put the T, my bad.
That's all right.
So S is what we're solving for, so I'm just going to do S question mark. So now we just need to substitute our value. So this is going in here, and this is going to go down here into T. So if I substitute, we should have S is equal to 2,345 divided by 315 seconds, and this is meters. So now this is a matter of solving, and I did this in my head.
Oh, that's impressive.
With the help of a calculator. Like I told the calculator what number, so I did do it in my head because I told it what to do. Our speed for this ends up being 7.4 repeating meters per second.
Okay.
Now, if you don't want to put SEC, you could just put S. We know what that means. Okay, now, if we were asking for a velocity, we would put which way we are traveling. But all I asked for is the speed, so this right here is my final answer.
Okay.
All right. Let's take a look at another one here. So this one, I love baseball. If you did not know, I have to find a way to go to the new Texas stadium. The Texas Rangers have a new stadium.
Is that where they're playing the
World Series? Yep.
Right now?
So I have to go back because I haven't been to every stadium anymore. I can't say that. It's a sad day. I will get over it. Moving on. Oops, I did it again. Don't do it. Don't do it. All right. So,
pretty serious.
I set you up. A baseball is thrown at a distance of 18 meters. What is the speed of the baseball if it takes a half a second to go? That's moving.
Ooh, that's flying. You don't want to get in the way of that.
Like Verlander fastball or Aroldis. We do. Moving on. All right, so again, let's go with our guess method. Okay, now it says, what is the speed? So we're not worried about the direction that it's traveling. So it just throws a distance of, so again, we're doing speed is equal to D over T. And our distance, it tells us, is 18 meters. And my time is 0.05 seconds. Okay. And then our unknown, again, is our speed, because it says, what is the speed of the object? So again, we're substituting. So this 18 is coming in here for the D, and our 0.5 seconds is coming in for T. So we have S is equal to 18 meters over 0.5 seconds, 0.5. Well, remember, when you're dividing by a half, it's really timesing by 2. But if you don't remember that, there is this wonderful thing called a calculator that you could use. And that should hopefully get us to, I believe, 36 meters per second.
Boom. There we go.
Yahtzee. Okay, so the first two we've done have been solving for time or our speed. Well, is that going to happen every time?
Not necessarily.
No. So now we have to figure out something different. So if Benjamin skated 80 kilometers at a 10 kilometer per hour, that's moving pretty quick.
Yeah.
How long was Benjamin skating? So this one, we're not asking for speed. We're looking for
We're looking
time.
for time. So sometimes people get this mixed up where they're like, how long? Oh, that must be distance. But you really have to read the context of it. So
yeah, how long? You usually would think how long would be a distance, but if I already tell you a distance, we're talking about time. Yep. So again, equation, speed is equal to
distance divided by time.
Okay, and a distance is given to me of 80 kilometers, and I have a speed of 10 kilometers per hour. So my unknown here is my time. Okay, now this one, some people are going to have a harder time with because of where our variable is going to be located. But I'm going to try and walk us through that. So again, we're going to substitute our values in. This 80 is going to go on top. This is where it's different, though, because this 10 isn't going on bottom. It's going to come over here to where the S. So this should be 10 kilometers per hour. And then this is going to equal 80 kilometers. And then the rest of this is just going to be divided by time. So this looks weird because we have something in the denominator. It's not that bad.
No, they can do
So
this.
would everybody agree to get something, if you're dividing something, the opposite of that is multiplying.
Right.
So we would then times both sides by t to get t out of our denominator because we don't like t in the denominator. So those two cancel each other out because they're opposite, reciprocals of each other. Sorry for using math terminology, everybody. So if I rewrite this, I'm gonna drop. So I have 10 kilometers per hour times the time equals 80 kilometers total. Well, we want to get t by itself. So what's happening to the t? We're multiplying. So to undo multiplication, we would divide then by 10 kilometers per hour on both sides. Running out of room. Well, notice my kilometers are going to cancel out. So all I'm left with is hours. So I have the correct unit because I'm dealing with time. So what is 80 divided by 10? Well,
8.
Even Mr. Spencer
did that in my head.
Yeah, never. I'll be nice. So it is 8 what? Hours. Because we have to make sure we put our unit with that.
Yep.
Okay, now, so this is the correct way to potentially work through this problem. However, I know some of you guys are not the greatest at math. So this is where sometimes that triangle comes in handy if we're struggling with this. D and T. Okay, but this time we're solving for time. So if I cover time up, I know my final answer is just going to be distance divided by my speed. And isn't that what we have? We have our distance here divided by our time, which is what we have, which still get us our 8 seconds. This just might be a little quicker way to get there, but also that's the mathematical way of working through it. All right, number 4. It took Sean 6 hours to walk to Susan's house at 2 kilometers per hour. How far is it between Sean's house and Susan's house? So again, 6 hours, that's a time. So I know if I'm just doing my givens, I have a time that is 6 hours. And it says walks to Susan's house at 2 kilometers per hour. So that definitely sounds like that's a speed.
Right.
And that was 2 kilometers per hour. All right. And then how far? So that would be my unknown. So that is my distance. That's what we don't know. We know our equation. So speed is equal to distance divided by time. And I know we're talking about speed because there's no direction.
Right.
It doesn't say east, west, north, south, or that way. That way is not even really good direction. So now we're going to substitute our values. So again, time is 6. So I'm going to substitute that in for time. And then I have 2, and I'm going to substitute that in over on that side. So I have 2 kilometers per hour equals my distance, which is an unknown, divided by my time, which is 6 hours. So we have our setup. Now it's just a matter of solving again. So I'm dividing by 6. So to undo that, the reciprocal would be to times both sides by 6 hours. So I'm dividing by hours, and I'm multiplying by hours, which cancel each other out, which just leaves me with my distance. So again, so we are on the solve here, everybody. Well, we have 6 times 2, which is?
12.
And this is just 12 kilometers. Okay? That is my final answer there.
It took Sean a long time to go.
He was lollygagging it.
That's definitely
lollygagging. 2 kilometers per hour, that's like...
Hey, maybe there was stuff to do along the way.
They got sidetracked.
It happens.
They had a dog. Okay.
All right.
I want
Jose.
We have Jose Jalapeno on a stick. So Jose wandered for 4 kilometers at 2 kilometers per hour. So this already sounds like we have our distance, which is 4 kilometers. And we have a speed that is going to be 2 kilometers per hour. So there's my G. My U, how long? But long is distance.
Yeah, so in this case, so you've got
long is distance
or it could be time. So we have to think about, okay.
Where's my equation? My equation is speed is equal to D over T. I already have D and I have S. It has to be T is what we're solving for here. All right, so again, substitute our values in. So again, distance is going here. And my speed of 2 is going over that way. Sorry for the crisscross there. So we have a speed of 2 kilometers per hour. That is going to be equal to 4 kilometers. And then we're dealing with time. So this, again, our denominator is a variable. So we're going to times both sides by t to get it out of the basement. So now we have 2 kilometers per hour times time is 4 kilometers. We're multiplying t, so we have to do the opposite. So we divide by the 2 kilometers per hour. Our kilometers cancel, so we are left with a time of 2 hours.
Makes sense.
Okay. Now, earlier we had talked about what happens if we have the units don't match up. Then we have to do some conversion. So this last one, notice, it says, what is the average velocity of an airplane? So we have 3 different options here. So we have, uh-oh, it went blank. We're good.
Crisis averted.
Crisis averted. We have 420. We're doing velocity. So this tells me my equation is V equals D over T. Mm-hmm. And how do I know that? Because it tells me due north.
Yeah.
It tells me due north. So what is the average velocity of an airplane that travels 420 kilometers due north in 1 hour? Well, this is easy because I already have my distance, which is 420 kilometers. And it tells me my time of 1 hour.
Uh-huh.
Well, anything divided by 1 is just that number. So I should have 420 kilometers per hour north.
There you go. Good.
Okay,
that
because
makes
we had
the
to have
velocity.
that. Okay. Now, the next one, I already see a problem. We only go 200. So I have my distance and I have a time. So this is 210 kilometers. But this is a half an hour. Well, that one's not too bad to try and convert back to because it's already in hours, right? So another way to write a half hour would be 0.5. So let's just go ahead and do 0.5 instead of the 1/2.
Okay.
So we have 210 kilometers divided by 0.5 seconds.
Not seconds, hours.
Oh, that's right, hours. My bad. So this is hours in 0. And then this is my velocity. So this also comes out to be 420 kilometers per hour north. Mm-hmm. Now, this last one.
Tricky.
Not really, because it gives me a distance and a time.
That's true.
So I could just do 105 kilometers divided by 15 minutes. And this comes out to be 7 kilometers per minute.
Okay, so that's the important thing is that you're paying attention to kilometers and minutes, things like that. So,
but that doesn't. How do we know if they're all traveling the same speed? Right now, you got I hope everybody agrees. A and B are both doing the same speed, but the last one looks like it's way slower,
right?
Because it's only 7 kilometers, but it's every 7 kilometers every
minute.
Okay, so we need to do a conversion to see if they're all actually going the same speed. So this 15 minutes we need to change into hours. Mm-hmm. There was only a way. Oh, wait, we do have a way. All right, so there's a lot of different ways, you guys, that you can actually do your conversions. Here's an easy way, is the picket fence method.
Yes.
Okay, so for the picket fence method, this top left part up here is my original unit that I'm starting with. So I'm going to put 15 minutes. What's my final unit I want it to be in? I want it to be in hours. So I'm going to put hours over here, and I want it to be, it's 1 hour. Mm-hmm. So this is where you guys have to think, how many minutes are there in 1 hour?
60.
Good. So we have
Last
60.
time I checked.
If there's more, we have a problem. Okay, so 60 minutes goes down here. Now, what's the nice thing is this picket fence is this minute cancels that minute, and we're just left with hours. Mm-hmm. So, and again, we're just going to multiply straight across here. Mm-hmm. So 15 times 1 is?
Still 15.
So 15, and then this is going to be hours now, divided by?
60.
Oh. So 15 divided by 60 is just 0.25 hours. Or, like you said, 1/4. Mm-hmm. 1/4 of an hour. So if we change this down here, so we are doing
105 kilometers.
So this would be 105 kilometers
in 0.25 hours.
Hours, very good. 0.25 hours. If we do that calculation, guess what it actually comes out to be?
I'm guessing 420 kilometers per hour.
That would be correct, Mr. Spencer.
Nice.
Okay, so the picket fence method for making sure your calculations are the same unit. So sometimes you might see a question where I give you something in minutes, but then I give you something else in seconds. So you just got to remember, hey, how many seconds are in a minute? Well, there's 60, so then you would just convert minutes to seconds or the other way around. All right, there you go, guys.
All right.
You can do this now.
You got this.